Welcome back, students. This is the explanation of RDT 2.1. In the previous classes, we studied RDT 1.0. It was a reliable and it was purely theoretical concept. And RDT 2.0, there we had bit arrays. And as a solution to this bit arrays to handle, the sender is wait for an acknowledgement signal from the receiver, that is ACK or NAK. This was introduced in 2.0, and if the ACK is arrived from the receiver, it says that the packet is arrived correctly. If NAK is received by the sender from the receiver, then what does it mean is the packet is having some mistakes or checksum errors are there. So the solution happened. The solution taken by the sender is to retransmit the packet, which is erroneous. So there we had some issues like what if ACK or NAK is corrupted. There was no solution for corrupted ACKs or NAKs to be handled. So if ACK or NAK is wrongly received at the sender, then sender is unaware of the wrong ACK or NAK. So it will retransmit the same packet. This may lead to duplication. That was the issue of the 2.0. These two issues are resolved in 2.1 by introducing a sequence number. That is 2.1 is an extension of RDT 2.0 plus 1 bit sequence number is added to this Then here in RDT 2.1 we have 4 different states. One is wait for call 0 from above. The opposite case wait for call 1 from above. That is 2 different states. One for the 0th packet and one for the first packet or the next packet. Then another 2 states. One is wait ACK or NAK for 0. Another one wait for ACK or NAK 1. These two states are waiting for ACK or NAK, but it may be at the 0th, waiting for the 0th packet, or it may be waiting for the acknowledgement of the packet number 1. And another difference you can see here is while the system is in the waiting stage, wait for call 0 from above, it will invoke the RDT send. Then the role of the RDT send is to make packets from the data. The packet number is packet number 0 for the first packet. Then it is as usual, checksum is computed, then send the packet. Then in the opposite side, RDT send, it is wait for call 1 from above. At that time also the same method is invoked, but only difference is this number is 1. That is the sequence number generated is 1. And alternatively, first sequence generated as 0th sequence number, then first sequence number, again 0, again 1, like that. It is a modulo 2 arithmetic. And the sequence numbers take only 2 different values, 0 and 1 alternatively. Similar to that of ACK and NAK, also take 0 for the 0th sequence number, acknowledgement or NAK is 0. Then for the first packet, ACK or NAK is for 0. Then let us consider the positive scenario. In every FSM, you can think the positive scenario as by taking the circular path. And at this time, the RDT send is invoked. It makes the packet 0 and send the packet. Then it enter into another state, that is waiting for the acknowledgement from the receiver. Once the packet 0 is sent, packet with sequence number 0 is sent, it wait for the acknowledgement 0. If the acknowledgement 0 is received, then it will go to the next stage, that is to make the second packet. Then wait for the acknowledgement of 1 or NAK of 1. ACK may be arrived or NAK may be arrived. Both these are received at the same stage. Then once the feedback from the receiver is arrived correctly. That is, if for the sequence number 1, the acknowledgement number should be 1. That time it will enter into another stage, that is sending for the next packet, and continuously the packet will send and the acknowledgement is received, next packet is sent, that packet's acknowledgement is received, and so on continuously. Each and every packet is continuously sent and acknowledged. This is the positive scenario. Then two different negative scenarios are explained here. This self loops represents the negative scenario. What is a negative scenario? Packet is received, or RDT receive is the method. Once the RDT receive method, this is invoked by the lower layer, or the endpoint of the link layer. That is when the packet is received. Packet is received means at the sending side the received packet is the acknowledgement or ACK or NAK. So ACK or NAK is received, and if it is corrupted or not, if it is corrupted or if it is NAK, in both these situations, carefully listen to this bracket. The inner bracket is the part of this OR operator. If any one of these true, then it will take as true. Then the outer condition is must, that is acknowledgement must be received. Then if it is corrupted or if it is negative, in both the situations, negative acknowledgement, that is negative acknowledgement says that the packet is received with error. So that time it is waiting or entering into an infinite loop. That is the meaning of this one. That is, till the correct acknowledgement is received, it will wait here itself. Positive, wait for the positive acknowledgement. Then only it will go to the next state, or transition will occur only after it receives a positive signal. The opposite case, that is, here also it is waiting for the acknowledgement or NAK1. If the packet is received and if it is corrupted or NAK, this case and this case are similar, no difference, but it is for each of the state handled separately. So the solution of the previous problem in the 2.0 was that if the ACK or NAK is go wrong, or if it is corrupted or not, the sender will be unaware of this, unaware of the wrong ACK or NAK. Then it will start send the same packet and it may lead to duplication. That was the issue of 2.0. So it is resolved here by checking the corrupted acknowledgement. Corrupted ACK or NAK is checked. That is what the advantage of 2.0. This is RDT 2.1 receiving side. Here also the sequence number is the important thing. That is, entire RDT 2.1 is working upon the concept of sequence number. And here we have two different states. One, wait for 0 from below, wait for 1 from below. In the receiving side, the invocation is from the bottom layer, or bottom part of the transport layer, or the end point at the receiving side. And let us think the positive scenario in this case. If the packet is received and packet is not corrupted, that is everything is positive, and it is waiting for the zeroth sequence. The received sequence is also 0. That time it is a positive case. Extract the packet, deliver the data to upper layer, and send an acknowledgement ACK to the sender, and the process is finished and it will enter into another state. This is the next state. At this state the same thing is happening, that is this one and this one, both are same, only difference is has sequence of 1. That is, the packet is received and packet is not corrupted, and the packet expected by the receiver was 1. That time the arrived packet is also 1. That is also a positive case. At that time, extract the packet, deliver the data, send the packet, send ACK to the sender, then the packet is sending. This is for the ACK sending to the sender. Okay, so this is the positive scenario, and two different negative scenarios for each stage. That is, these self loops are representing the negative scenario. Two different negative states. One is if the packet is received and packet is corrupted, um, corrupted, then it is a negative scenario. At that time it will send NAK. The opposite case also here we can see a packet is received and it is corrupted and it will generate an NAK. This for sending the NAK to the sender. Then another case is this one, that is packet is received but not corrupted. That is packet is okay, but it was waiting for call 1, but the arrived packet is sequence number 0. Here there is a mismatch. At that time also it will enter into the infinite loop. That is, this will wait until it receives the expected packet. That is, it is waiting for 1. If the sequence number 1 is the packet received here, then it will enter to the next stage. Otherwise it will wait here. The same thing is happening here also at the receiving side. Packet is received, packet is not corrupted, but it is not the expected packet. Packet number is varying. That time also it is enter into an infinite loop or wait for a long time until it receives the expected packet. The same thing is explained here, RDT 2.1. Here we are introducing a sequence number. Alternate sequence number 0 and 1 is used. That will be sufficient for representing all the packets, and ACK and NAK concept is same, but one additional thing is performed in the receiving side is ACK is corrupted or not. That is checked at the receiving side. Then this is explaining in the 2.0 we had 2 states at the sending side, whereas here we have 4 states at the sending side. Then in 2.0 at the receiving side there was only one stage. Here we had 2 states. Double is the number of states in sender side and the receiving side. Then at the receiving side it is checked for the duplication. That is also performed at the receiving side. This is what the important thing, which is eliminating the duplication of the packets by implementing the sequence number. Then RDT 2.2, here we have an addition to RDT 2.1. That is the drawback of RDT 2.1. Actually it is just one improvisation to the RDT 2.1. That is, all the concepts of 2.1 is there in 2.2, but here it is avoiding the NAK. Instead of NAK, the second bullet, it uses only ACKs, and ACK will be provided for the last arrived packet. That means if a packet is acknowledged with acknowledgement number 1, that means the previous packet is arrived safely. That we will see in detail in the coming slide. Thank you.